So one of the biggest issues in teleoperation is providing enough capacity to run robots. That problem is one of radio communications that doesn't allow you to transmit enough signal because the government regulates your ability to send enough capacity to run telerobots. Most people have been focusing on changing the robots to autonomous robots so they need minimal communications with them. One of the problems with that is that when you get into difficult environments like subsea or in mining environments, you cannot take the operator out of the loop yet. That meant we had to look at a new type of communication system that would be localized and allow us to be able to get the kind of capacities or bandwidth that we needed to be able to run those robots.
What you see here is we have a CCTV camera, and that camera is linked via Ethernet to the transceiver over here. The blue LEDs that are in there are transmitting Ethernet protocol over TCP/IP to this box and received in the center of the unit with the receivers in a lens fashion that takes all the signals in and gathers them and then transfers them through to the screen. And so this communication can go in both directions. So we could put a camera on this unit here and have it go the other way as well and come back. That's been built specifically in this fashion with a conical shape to take away the problems of the directionality of light and turn it into a communication system that can allow you to flood an area like a cell phone tower. By doing that, we can then put them on moving robots so that as the robots move, they're always in coverage. It's like there's an aura about them of light. We can run extremely high bandwidths through here and throughputs that allow us to run many robots as we build the systems up. If you're underwater and you want to get a bunch of data to come to you about a tsunami warning system, for example, to a glider that's got to come to it, where previously you were going to be transferring it at a few bits per second, but now we can do it at these extreme rates. They would go on to vehicles that would have their own power source, or if they wanted to be freestanding, we've looked at how you could use saltwater batteries, for example, to run them for extreme lengths of time and leave them in place in the ocean in a pattern that allows us to mine a particular area.
So what you see in behind us is the optical communication system working from one end of the pool to the other. We have a green transmission system at this end, far end, and a red orange transmission system at this end. Alberto's at the other end of the pool with the computer and camera that are looking back towards us so that we can see the communications that we're able to achieve. So what you see on the screen here is a window that has a webcam from the other end of the pool. You can see as I wave my hand that it's a slow speed of myself down from that camera. That camera is being transmitted back to this computer via the optical communication system. You see the pinging that's going on a regular basis that lets you see how often the communications network is being pulled. The final piece that we're just going to play for you is a movie of a hockey game that is actually on the far computer and being transmitted across the optical communication system to this computer screen. You can see how good a quality the image is, but it really truly reflects the speed of the communication that's going on at probably in the order of 30 to 70 megabits per second across the pool, which is very important because that rate of communication, this is the first time that we're aware of that that's ever been achieved. What we have are the same two units that were in the pool, one green and one red, but now they're 10 feet deep in the lake water, which we haven't yet characterized the lake water to understand it, but we're transmitting and receiving from both those units. On this unit, you can see we have 26 megabits per second being transmitted from the red optical communication system. That is what's
being transmitted so you can see the video on the other screen, because it's running off of this computer here and being transmitted over to this one. So the video actually resides over here, but it's being transmitted over to this via the optical communications in the lake. The same thing's occurring from the other one at the same time, where a video on this computer is being transmitted over the communications network back into this computer, which is allowing us to look at that video in its full motion, the way that it should be. And so we're able to do this over a distance right now of 20, 24, 25 feet. We'll be able to now characterize the water, and the new domes that we're currently under construction that are full spheres, those will solve all of the relative issues. Because today the two plates that we're trying to match up are very hard to align. So once we get them so we can align them straight on, or we can get the domes, which means that you can move them all around and look at them from all angles, we'll be able to get much better communications over much greater distances. So far, success to get to this point, because now we're increasing the range of what we're doing and being able to get the transmission distances out at the levels that we need them to be.